রেকর্ডিংটা মনে অন হয়ে গেছে। আমাদের ক্লাস লেকচারগুলো ইংলিশেই হবে। এমনিতে ক্লাসে আমরা কোশ্চেন করার সময় বাংলা ইংরেজি যে কোনোতে কোশ্চেন করা যাবে, বা অনেক সময় আমরা বাংলাতেও কথা বলবো। তবে মেইন লেকচারগুলো যেহেতু কন্টেন্টগুলো সব ইংলিশ, আমাদের লেকচারগুলো সব ইংলিশেই হবে। মিডিয়াম অফ ইনস্ট্রাকশন ইংলিশ সেই হিসাবেই হবে আর কি। So we can start now. So welcome to machine learning course CSE 533. This is an graduate level machine learning course. So we'll have some advanced stuff here that normally are not covered in undergrad courses. For example, we'll cover cover machine learning, neural networks. So some part of deep learning. For example, we'll cover basics of neural networks and feed-forward neural network, and also we'll try to cover convolutional neural network. So only these two advanced stuffs. Other than that, we'll only discuss machine learning algorithms. But even for machine learning algorithms, we'll discuss some mathematical intuitions. We'll not try to use lots of equations to understand things. Mainly, we'll try to get an idea based on the mathematical formulations, especially linear algebra and probability. Because without linear algebra and probability, it is impossible to learn any machine learning or deep learning. So we'll cover some of the topics from these two topics. Basically, the basic topics, the most basic topics that we need to understand machine learning algorithms or some form of deep learning algorithms. Now, at first, we'll discuss some introductory stuff about machine learning. So the first question will be, what is machine learning? So we can now most of us have idea about what is machine learning. In one word, machine learning is data-centric programming. In one sentence. So what do we mean by data-centric programming? We try to learn from data in machine learning. In conventional programming, we set the algorithm, we provide input to the algorithm, and we get some output. But in machine learning, we try to learn from data. For example, if we want to flag spam in emails, we need to find out some criteria to flag an email as spam or not spam. And if we want to do that, then if we use machine learning, then we'll collect some examples of spam, examples of not spam, and then we'll feed these to a machine learning algorithm. The algorithm will decide how it can classify spam or not spam. We'll not tell the algorithm anything. We'll provide the algorithm some data. That's all. But for conventional programming, we'll do the opposite thing. We'll develop some rules, and this rule we can develop the rules using by checking the data, but by checking the data as human perspective. And then we'll develop some rules, and the algorithm will use the rules to decide if a mail is a spam or not a spam. So here we can see, if we don't use machine learning, we'll study the problem. So if we don't use machine learning, we'll study the problem first. After that, we'll write some rules. How would we write rules? It's based on experience, our findings, kind of heuristic. And then after writing the rules, we'll evaluate the rules. And if evaluate means we need some criteria to check if we are right or not. and then we'll evaluate, and then we'll launch. So this is the case if we don't use machine learning. So we are just trying to develop some algorithms or rules. Now, if we use machine learning, then the system will be different. So we'll start from data. And then using the data, we'll train our models. So we are not saying that we'll find any rules. We're saying that we'll train the algorithm based on the data. And we'll evaluate our solution, like how good are we doing, and then we'll launch. So after launching, we'll update data, and after updating the data set, we'll have more data to train, and then maybe we'll use more data to find a better model, evaluate the solution, launch, and this thing will continue. So basically, if we use machine learning, we are starting from data. Now the question is, why do you want to use machine learning? So if we can write rules, and if there are many programmers around the world who can write rules, why do we need machine learning? We can solve the problem in a different way. We don't need to basically develop a new field that can solve the old problems. But there are some this is actually not the case. So these are old problems, true. For example, spam detection, or most of the problems that we solve now, those are very old problems. People are trying to solve those problems for maybe 20-30 years, but recently we can collect lots of data. Now, if we can collect lots of data, maybe there are some patterns in the data that we don't know, or maybe there are some patterns in the data that we'll understand in future. But if we peek into the data, you can use them right now. So if we don't have any technology that can peek into the data and find rules, well, by the time we'll develop something, maybe our hardware will be obsolete. So basically, will not be able to keep pace with the problem if we don't develop a method that can peek into the data and find solution even before we can peek, even before we can understand that in future. So that's one thing. Another thing is the problem space is changing. For example, for spam detection, maybe we can find some basic rules. For example, the spam will have some words that can attract people. For example, credit card, amazing, free, new offer, and also maybe they'll have some words based on from where the spam is coming for you. Maybe if it's from India or China, they'll have some specific words. So it's true, we can use those words as a pattern, like, okay, in spam email, this or the probability of appearing these words.
ওয়েটিং রুমে মনে হয় মানে ওয়েট করতেছে কয়েকজন।
Okay, I think they are admitted now. So maybe we'll find some words. It's true that those words will be present in spam emails with high probability. So we can write rules for those words. But pretty soon the spammer will catch up. They will change the words. They'll come up with new words, and then we'll have to again write new rules. So pretty soon we'll find that there will be hundreds or even thousands of rules based on different locality, based on different languages. So the rules will be complex. Some of the time rules will be broken, so the system will be broken pretty soon. On the other hand, if we can find a system that understands the pattern all by itself, then if the spammer changes the words, or if the spammer come up with a new way, maybe the algorithm will be able to find it. So that's why we use machine learning. So machine learning algorithms, they're specialized in find patterns from data. So if there are some data and there are some patterns, obviously there should be some patterns, then the machine learning algorithms can find it with high probability. So that's why for some problems, mainly data related problems, we use machine learning rather than conventional programming. So that's we already talked about it. So if you use machine learning, the algorithms will be able to find out patterns all by itself from the data. So we do not need to find rules for the algorithm to classify spam from not spam. Also, there are some problems. Okay, I'll take a 2-minute break, 2 minutes break, then I'll continue. Okay, we can start now. So another problem, if we don't use machine learning, is the variation in the data set. For example, if we try to develop a speech recognition system using just rules, it will be very complicated. For example, people have different accents based on countries, localities, even different regions of the country. So if we want to develop a system that can understand all the variations, it will be really, really complex. On the other hand, if we use machine learning, which basically uses probabilities and statistics, then it can capture the variability in a concise and mathematical way. So it will be easier for those type of algorithms to model the problems. So basically it will be easier if we use math and statistics and probability rather than using rules or algorithms. Another use case of machine learning is to gain insights. For example, space exploration. So normally scientists capture images from using different telescopes, and then they need to analyze those images. So one way is to explore using machine learning. So they try to capture different statistics using machine learning algorithms from the images, and then based on their findings, maybe they try to capture different part of the image, or maybe they can capture different wavelengths for the images, and something like that. So basically, we can use machine learning to gain insights into the data, and later we use those insights to explore more or find something new, or decide what to do next, only using machine learning. So to summarize, there are some
hello, sir.
Yes.
Sir, so machine learning is all about data.
It's mainly how we can program using data.
So is it মানে এখানে কি অ্যালগরিদমটাকে মানে ইউজ করা হবে? আমি অ্যাকচুয়ালি মেশিন লার্নিং এর ফার্স্ট স্লাইডটা মিস করেছি স্যার, সো দ্যাটস ওয়াই আমি আস্ক করছি।
No, it's okay. So basically we'll use algorithms. So it's not that we can't use algorithms. We will use all the algorithms that we studied in computer science, especially the data structures and algorithms, but we'll use those algorithms with statistics and mathematical models. So just understanding loops, just understanding rules, just understanding how the algorithm works is not enough for machine learning. For machine learning, we need to learn some math and learn some statistics. So basically, it's an applied computer science which discuss how we can integrate the knowledge we gather from conventional computer science with statistics and mathematics. Basically, when we deal with data, normally data have some variability and some maybe higher dimensional component in the representation. So we want to capture those and use algorithms to integrate with other systems. So basically, we need to learn only not a lot, but few statistics and mathematical models, and then use the algorithmic background we have to integrate more data to the other conventional computing systems. Is it clear now?
Yes, sir. But is it similar artificial intelligence or not?
Yes, it's a part of artificial intelligence. So artificial intelligence is something that that is a system that normally we think only human can. Basically, somehow there is a human component in that. So it needs to think rationally to work as a system. Now, if we can put the rationality into a system, then we call that system artificially intelligent. Now, machine learning is one of the way to assimilate intelligence into the system. So we basically take patterns and intelligence from the data and put that into the system so that the system can later be identified as artificial intelligence.
So we can say machine learning is a part of artificial intelligence.
So we can say that it's a way to put intelligence into a system.
Okay, sir.
So basically, how we put intelligence in system, how we can say that it's working intelligently. So we use machine learning to find basically what's the norm from the data set and find a model that can be assimilated with the system, and the system using the model work rationally.
Okay, sir.
স্যার আরেকটা কোশ্চেন ছিল, মানে এই কোর্সটা হচ্ছে আপনি কিভাবে নেবেন, লাইক আমাদের কি মিড টার্ম হবে বা হচ্ছে প্রেজেন্টেশন বা প্রজেক্ট কি কি থাকবে, এই জিনিসগুলো একটু বললে ভালো হতো।
I'll discuss those after the lecture.
ওকে স্যার।
So machine learning, we can say that normally can deal with lots of data, and there are some complex problems for which there could be many solutions. And if we want to try to use conventional solution, we'll have to find rules for many different cases. But if you use machine learning can use statistics to capture the variations, and also in some cases the environments are fluctuating. And finally, we can gain insights for complex problem using machine learning algorithms. So there are many types of learning systems. So there are many categories, and they are categorized using different criteria. For example, how we use the training set. Training set means how we use the data. Based on that criteria, we can find 4 categories of machine learning systems. First one is supervised. So we'll discuss those later. Then unsupervised, semi-supervised, and reinforcement learning. So based on how we organize the example sets, and then how we learn based on that criteria, there are 2 categories of system: online learning and batch learning. And finally, how do you want to build our model? Based on that criteria, there are 2 kinds of systems: instance-based learning and model-based learning. So at first, supervised learning, I think most of us already know. Supervised learning means the example sets are tagged. So maybe our data set have many different classes, and our problem is a classification problem. So if we can find a data set where the examples are already labeled, so for each example we know what class it belongs to. If the data set is like that, and we develop a learning system based on such examples, then it's it will be a supervised learning algorithm. Now, there could be one example of supervised learning is linear regression. Normally, for linear regression, we have we get a data set along with a value. So for data set, a sample along with a value, another sample, another value. So we get a data set where there are many samples, and for each samples, we know the output. So that means we have examples that are tagged. So that's why it's called supervised learning problem, and regression is one example of that. In this course, we'll discuss all the supervised learning algorithms: linear regression, logistic regression. Even if it's a regression, it's a classification problem. The second one, logistic regression, it's a classification problem. It's a linear regression is the regression problem. And then we'll also discuss support vector machines, some ensemble methods, decision tree, random forest, and we'll also discuss neural networks. The unsupervised learning, normally these algorithms deal with datasets that are not tagged. So we get a dataset and that's all. Now we need to somehow make sense from that dataset. Normally, what we do is find different categories, and sometimes we try to find hierarchies. Even for tag dataset, we really have different categories. So tag dataset means they are divided into classes. Using unsupervised learning algorithm, we try to do the same thing, but without any hints from the input dataset. So maybe we use some other sorts of statistics, some other sorts of probabilities or statistical theories to find hierarchy, clusters, or some sort of categories in the dataset. Then we can mix that with other algorithms, but first step is to find some categories.
Sir,
Yes.
আচ্ছা, labeled and unlabeled এর difference টা হলো যে unlabeled এ maybe solutions গুলার সাথে basically দেখায় না, right? Key value pair যে এই input এর থেকে ওই output আসতেছে এরকম কিছু?
So normally we have data set like this. So these are features, and normally one is the label. So there are many features. Now, for supervised learning, there will be features, and there will be some predefined labels, and this is called a sample. This is called a sample. Each row is a sample. So each sample will have a tag or a label for supervised learning problems, and this tag or label will be this will be done by by human basically. So people or other data collectors, they will put some labels here for supervised learning problem. For unsupervised learning problem, there will be no labels, just features, that's all. Now, based on the features, we need to find these labels using unsupervised learning algorithm. Is it clear?
Sir, supervised learning or unsupervised learning er real application কি হতে পারে? Real life application example.
So we'll discuss in future, but just for one example, for supervised learning, maybe we are trying to build a vision system for a self-driving car. Now, for supervised learning, we will put some labels for broken road pavement, maybe some objects in the road for this type of scenarios. And for unsupervised problem, maybe language or NLP is the best example. So we have text all over the internet. Now, based on the text, we build some unsupervised learning model, because who will tag all this text for us? Even if we try that, it will be too costly. Even for a government, it will be too costly. So to label all the text in the internet. So we better devise a unsupervised learning algorithm that can find some patterns in the data all over the internet. But for like self-driving car, we know that there will be a road ahead, there will be a pavement, maybe there will be a broken pavement, some objects in the road, or there are some hazardous conditions. So those are some tractable solutions. So we can employ some human, who can take some pictures and label the road pavements for us. So could I make it clear to you? Did you understand what I tried to say?
Yes, sir. Clear.
Any more questions?
No, sir.
Okay. So for unsupervised learning, there are many algorithms because we try to find categories using different perspective. There are many categories, many perspectives, and based on that, there are many algorithms. For example, if you want to cluster the data, then there are mainly 3 famous algorithms: K-means, DB-scan, and HCA. If we want to find outlier or anomaly, then we can use either 1+SVM or isolation forest. If we want to deal with the dimensionality for unsupervised learning dataset, we can use PCA, we can use autoencoder, we can use kernel PCA. If we want to really just to visualize the data using unsupervised learning algorithm, we can use t-SNE. We'll not cover most of the things, but we'll cover maybe K-means and t-SNE from here. So this is an example of clustering the unsupervised data for unsupervised data that do not have any labels tagged by human. So this is an example of anomaly detection. Normally in anomaly detection problem, most of the data are in one cluster, maybe 1, 2, or 3, or very few data in another cluster. So basically, we want to find out who are the outliers in the data set. So now we can mix supervised with unsupervised, and we call them semi-supervised learning algorithm. For example, sometimes Facebook cluster the images based on human face. Now maybe for some faces, Facebook does not know the name, so they cluster the images based on that unknown face, but Facebook waits for someone to tag that face, and whenever someone tags that face, then Facebook categorizes all the images for that name. So basically, it's a semi-supervised learning algorithm. At first, Facebook uses unsupervised learning, and then whenever someone puts the name, it starts supervised learning for those clusters. Now, based on how we reinforcement learning, we can tell it's a kind of supervised learning, but it's a kind of a real-time supervised learning. So the system at first starts, and then it tries to output something, maybe based on the environment or something, but basically it tries to output something, and that output is evaluated. We can either reward or punish that output. So if we reward the system, then the system understands that whatever it did was okay, so it learns that way. On the other hand, if we punish for that outcome, then the system understands that it was something that it should not do in future, and updates the learning model based on that. So it's a kind of reinforcement learning. It's a kind of supervised learning, but more like real-time supervised learning. Someone instructs the system, but not before, after the system has done something. Now, based on how we use the data set, there are 2 kinds of learning. batch learning and online learning. For batch learning, that means the learning algorithm that we are trying to build. The learning algorithm that we are trying to build, it cannot learn on the fly. So we must provide all the data. Based on the data, it will find a model. And now, if we provide just one data point or one sample, it cannot learn. So then there is no other way. We need to use all our data set before we can put a model in production. So we give the model all our data, and based on that, the model is trained, and then we take the model and we put the model in our production system. Online learning, on the other hand, they can learn on the fly. So at first they.
Sir, regarding offline learning, can you give the real life example about offline learning?
So for online learning, one example could be
offline, sir, previous আগে যেটা পড়ানো হয়েছে।
So for offline
এটা আপনার হ্যাঁ ব্যাচ লার্নিং যেটা আর কি, ব্যাচ লার্নিং যেটা, এটা আসলে মানে রিয়েল লাইফে মানে আসলে কোনটা আসলে কিভাবে এটা একটু।
Okay, so for batch learning, normally the neural network based algorithms, they use batch learning. So basically, they learn using gradient descent algorithm that works best for small batches. So we provide the algorithm the batches, and then based on that, the algorithm learns. Now, for conventional machine learning algorithm, for example, nearest neighbor algorithm, that can learn online basically.
Okay.
So maybe after we get a new instance, and then we find its nearest neighbor, and then in the same steps, we can also put it in a cluster with its similar neighbors, so that later the learning becomes faster. So we can do it real time. It will be really fast. It will not hamper the timing of the outcomes. But for neural network based problem, the learning is challenging because they use all sorts of optimizations and gradient descent, which requires multiple steps to learn. So if we start learning while we provide output to the users will face significant delay to get an answer if we use batch learning, online learning for neural networks. So is it clear too much? So I don't know who asked the question. Your name here shows some BD and Zoom. What's your name? Hello. I get a number like 68.
Yes, sir.
What's your name? Oh, okay.
Hello,
Hello.
sir. Are you asking something?
Yes, I'm asking a name of a person whose name is written as https bdrain.zoom.us.
No, sir. Anika Hussain. Sir, আমারটা কি নাম শো করছে না?
Has asked the question just a few minutes back. Sir is asking for him.
Oh, it's okay. It's okay. Don't have to tell your name. It's okay. I'll continue with the lecture. I hope you understood.
Sir, online learning means this a real time, like we have learned about real time processing, like that. That something will come in front. I mean, current situation, they will just try to grab that one.
So basically, the learning is lightweight. So we can serve and learn at the same time. So you can serve the users, and then based on how the user reacts, you can learn. So the learning should be really lightweight. Now, if the learning takes time, then if we are serving the users and trying to learn at the same time, the system will be slow. It's not that we cannot use online system for neural network. You can, but it's not practical.
Okay, sir.
And based on how we use the examples, there are two kinds of algorithms: instance-based learning and model-based learning. Normally, instance-based learning, they are suitable for online learning. So we keep the data set we have, and whenever we encounter a new data set, we try to find closer points to that new instance. For example, here, maybe we have this data set, and we just got this new instance. Now, to find a category for this new instance, we find the distance from the to all the members of our stored data set, and then maybe we can take a majority vote. For example, this new instance, it will be labeled as green triangle. So this is instance-based learning. That means after we learn, we cannot delete the data set. We need to keep the data set. Model-based learning, on the other hand, we learn from the model and then we don't need the data set anymore. For example, linear regression. So use all the data sets to find to learn some weights for a model, and then after we have learned our weights, then we don't need the data set anymore. Whenever we get a new instance, so this is basically the model boundary. There will be a function that can understand if the instance is inside the boundary or outside the boundary. So basically, we will forget all the data that we use for learning, and model will only capture that there is a decision boundary. So for new instances, we do not need the previous data, we just need the model. This is called model-based learning. But for instance-based learning, we need to keep our data for new instances to check the distances. There are some problems with machine learning. First one is insufficient. We'll discuss all this. First one is insufficient quantity of training data. So for building a good machine learning system, we need lots of data. So if we don't have enough data, then our model will capture wrong information, will have wrong rules, because it can only learn from data. And if the data is not coming from all possible domain, the model will be wrong. So insufficient quantity of training data is a great problem for machine learning. And also collecting data is costly. So if we really want to build a machine learning model, we need to collect a lot of data, and it is costly. But after we build a model, if the collected data was from all the subdomains of a particular domain, the model will provide us with very good results. Another problem is non-representative training data. This is also a problem for cost and also interpretation. Maybe we will collect life satisfaction data from all over the world, and then we'll try to build a model. Now, the problem is life satisfaction depends on countries. Now, for Western countries, they rate their satisfaction in a very different way than people in Asia or China or Japan, they rate. So if we want to build a model, then at first we'll have to collect data from all over the world, first thing. And the second thing, when we build model, we need to keep in mind that we need to build multiple models, not just one model, because people rate satisfaction in many very different ways based on locality. So based on locality, maybe we need to build a couple of models, not just one model. Another problem is poor quality data, because data collection is hard. Maybe we are employing someone to collect the data, but they're lazy. Maybe they're not collecting data, and they're putting some random numbers. And when we get the random numbers, obviously they will not be representative for the real world. So we'll have poor quality data, and because of poor quality data, our models will be poor. Irrelevant features. So this is not a problem for the data collectors. Irrelevant features are basically a problem in the design. Maybe we are collecting features, and some of the features are combination of other features. So if it's a combination of other features, then if we keep both the features, it will be relevant, and because it's relevant, it will introduce errors into the model, because we are end of the day we are using statistics. Now, if we use if we use more numbers than necessary, the more numbers will increase the boundary of the error. So irrelevant feature means if we use too many irrelevant features, that means our models will be faulty. The boundary of the error will be huge. So we need to use feature selection, and we need to use feature combining. So basically, we need some kind of feature engineering if we want to build good models. This was true for conventional machine learning, but for deep learning, the feature selection is automatically done by neural networks. So now we just use neural networks and different kind of regularization, and based on the regularization and and the specialized neural network algorithms, feature engineering is automatically done by the algorithms. Another problem for machine learning is overfitting. So because we are trying to find a model, and normally we do not know what model is sufficient for the data. Most often we start from a very complex model, and if we start from a very complex model, then the model can memorize the data set, and that's called overfitting. So basically, we see an example here. So this model means this is the model, and these dots, this is our data set. Now the model, we see that model tried to memorize the data set, and for memorizing the data set, the model needs huge fluctuations. So the model is going over the board to capture these data with this data. Now, if we later find some data here, maybe we'll get a data point here. So we'll if it's a regression problem, we'll output maybe minus a very large number. But we see that it should be somewhere here. But the complex model, it fails to capture that, because we're using too complicated model. It's trying to memorize, and in the way of memorizing, it has like very big jumps here and there. Another problem is underfitting. So if we think that, okay, the model became too complex, then start with a very, very simple model, then it cannot even understand the data. It's called underfitting problem. Sometimes it's called bias problem, and sometimes it's called variance problem, because it varies a lot. So it's a variance problem, and it's a bias problem because it cannot capture the pattern in the data, so it has a bias basically. So that's why it's called a bias problem. And finally, after when we do model selection, so we already saw that if we take too complex model, it's not good. If we take too simple model, it's also not good. So we need to find a model that is in between. Model means a mathematical somehow formula. It will have some parameters. Now, if you have too many parameters, that means we may fall into overfitting problem. And if we have too few parameters, that means the model we may fall into underfitting problem. So we need to find some number of parameters in the middle, not too high, not too low. The problem is we do not know what do we mean by too high, and we also don't know what do we mean by too low. So basically, we need to find we need to explore a hyperparameter space to find out the right parameter and hyperparameter. So for that, we use model selection. So we'll also have a lecture on model selection. Then we'll learn how we do that. So now we'll take a break, and after the break, we'll start Python programming, and then after Python, we discuss some Python programming. Then we'll discuss about the course, like when will be the midterm, how many quizzes will there be, when will be the final exam, weight and distribution, about the projects and everything. Okay, now I'll give you 10 minutes break.
Okay, so thank you.
Hello, can you hear me?
Yes, sir. Yes.
Yes, sir.
Okay, now we shall start Python programming. We'll need Python programming for the project. I think all of you already know Python programming, but to to take everyone in the same page, normally I discuss Python programming in the first lecture of the course. So we'll discuss only the basic features. So even if you know, it will be a brush up for you. So this slide basically contains most of the important features of Python. So if you can understand this slide, hopefully you'll be able to start the project. In these slides, at first we see we defined a dictionary or hash map or hash table. Then we are defining a function, and to define a function we use the keyword def, name of the function, then the parameter list. For the parameter list, if we want to use the default argument, we can do it like C or like C++. And then for if, we use if block, and for loops, for example, for, we can use for and this syntax. You can even use raise to throw exceptions, and then we call this function using this construct. Now here we can see that to define the body of the function, we are using colon and then some indentation. So we are not using any curly brackets for if, for block, for a function, and we'll see later that even for defining class, we just use colon and then indentation for defining any blocks in Python. So indentation matters in Python because we define block by the number of indentation. For example, here for defining the block of this function, maybe you're using for
নিচে if name equal to main, ওটাতে কি বোঝাচ্ছে স্যার ওখানে?
This one is for, like in Python, it's a interpreted language, and normally the compiler starts executing from the beginning of the file, like line number 1 in the file. So if we compile this function will define, but no one is calling it. So normally using this construct, we are telling the interpreter to call all of the codes in this file starting from here. So it's basically main function in Java or C++, and there is no main function in Python, but it's a way to communicate with the compiler that this is the main block. The compiler will take that and will start executing from here. Yeah, we are using special keywords and special symbols for that. Normally, there is no main function or main, even for classes, there is no main, but we need an access point to a program. So basically, we define the access point using this construct. Is it clear?
Yes, sir.
So indentation matters, and the main thing is in the indentation matters mean the indentation for the same block should be same. For example, for this method, approximate size, if we start the indentation as 4 white space, we need to keep 4 white space for all the blocks of this function. Now, when we start if block, we can use 2 white space to define the block for that if. It's not a problem. But if we start with just 2 white space, then the rest of the statements must follow the same indentation rule. So if we have another statement like after this, for the if block, it must also have 2 white space if the first line has 2 white spaces. And for this function, now maybe we're using 4 white spaces. Now, if we use 4 white spaces for the first statement, then the rest of the statements for this function must use 4 white spaces for the to maintain the block. So that's the rule. Because Python is interpreted and dynamically typed, we can just write the name of the variable and assign some values to it. We don't need to define the type of the variable. Like C, C++, Java, we use equal operator as assignment, double equal operator as a comparison operator. The arithmetic operators plus, minus, multiplication, division, modulus operator, they're same. There is only one difference. For logical operators in Python, we don't use symbol. Normally we spell them. And the basic printing command for Python is print. Python has 4 basic data types: integers, floating point values, strings, and boolean. For boolean, obviously there are 2 values, true and false. But in Python, we need to capitalize the first character of true and false. Any question? Do you have any questions?
No, sir. No.
Okay. Okay, so there are mainly 4 basic data types: integers, floating point values or doubles, strings, and booleans. Now, as we discussed, white space is important because we don't use any curly braces to define the blocks, we use white spaces. Now, for single line comments in Python, we use hash sign. So whatever in the line after the hash will be regarded as a comment. Yeah, so it will be used for only single line comment. Now, if we want to use multi-line comment, then we need to use triple quotes. So triple quotes, another use for triple quotes as doc string, as a like documentation for the functions, but we can also use it for defining multi-line comments. The naming rules is same as C, C++, Java. We can use any names as variable names other than the reserved keywords. That means for Python, and, assert, break, while, try, loop, return. So these are the keywords. You cannot use these keywords as variable names. Also, we cannot keep the first character of any variable name as numbers. So the first character must not be a number. We can use numbers in any other position of a variable name, but not the first character. So naming conventions, it's mainly connected with software engineering. So when we define variable names in Python, normally some of the variable names will have multiple parts, and we can use either any of the conventions to define those names. For example, we can for the different parts we can join them together using underscore, or what we can do, like make the first characters of different words capital, or we can use camel case, the case that Java uses. So it's okay if we use any of the convention, but we need to be consistent. If we start using one, we should keep using that one only. If we mix, then it will be a problem. It's not that the compiler will throw an error. Compiler will be okay, but the future developers who may want to modify or update the code, they will face difficulties, and sometimes they'll not be able to do it. Now we'll discuss different data structures for Python. At first, we'll discuss the sequence data types. For sequence data types, Python has mainly 3 containers: list, container classes, list, update, and list, tuple, and string. So all of them are finite order and finite ordered sequences, and they're indexed by integers. So we can define tuple using bracket like this, and then the elements will be separated by commas. Now the elements can have any data type. It's not that tuple should contain only one type, like C++ or Java. Normally in C++ or Java, we need to define a container of some type, and we can only keep data of that type in that container. But for Python, this is not the case. For example, here we are defining a tuple with integers, strings, and another list, another string. We can even use Boolean, whatever we like. For strings, the rule is strict. Rule is different. For strings, these are the elements, but all of the elements must be characters, or maybe Unicode characters. But they should be characters. It's not that they can be of any object type. And for list, again, like tuple, they are separated by commas, and they can be of any type. Now, it may seem that tuple and string are the same things. Yes, they are almost same, but list is it's a mutable container, but tuple is an immutable container. Strings are also immutable. Now, all three sequence types, they share some of the functionalities. They share some of the syntaxes, and they share some of the functionalities. And that's why they are all sequence types. For example, we need to index them. How we index them, how we access the elements. So those are same for all the container types, but there are some differences. For example, tuples and strings, they are immutable, and lists are mutable. That means we can modify them after we create them. Mutable means we can modify them after we create them, and tuples and strings, we cannot modify any of the elements after we create them. It's not that we can change the element. And also there is another difference. For strings, all the elements must be of just one type, characters. And for lists and tuples, they can be of any type. Now we can define
arrays কোনটার মধ্যে পড়ে?
So basically we can say list in C. If you think about C++ array, there should be list. But dynamic list means we do not need to define the size while we at the beginning, and also they can hold any type of object. In C++, Java, we need to define the type of object that array can hold, but in Python they can contain any type of object, and also there is no size limitation. Clear?
Yes, sir. So arrays are mutable.
Array is mutable. In C++, array is mutable. Yes. Mutable means we can change it. In Python, list is mutable, but tuples, they are not mutable.
What about arrays? মানে আপনি তো বলছেন arrays লিস্টের মধ্যে পড়ে, so does that mean arrays are also mutable?
So I said that arrays of C++ or Java, not Python. So for sequence type, Python has 3 containers: lists, tuples, and strings. Arrays is not one of them. Arrays of Java or C++, they are mutable. So I'm comparing Python to Java or C++. So Python, Java or C++, they have array data type.
Also Python arrays নাই?
No. So for
Okay.
container, we use tuples, lists, or strings. Is it clear now?
Yes,
No,
sir.
sir.
Okay.
স্যার যখন হচ্ছে যে আমরা ম্যাট্রিক্স করি, তখন কি টুপলস, লিস্ট এই জিনিসগুলো কি ইউজ করা যাবে?
We use normally lists.
So
Normally
list
list
means
can be of 2-dimensional,
it can be
3-dimensional.
number. Sorry.
List can be of 2-dimensional, 3-dimensional, or n dimension.
So list like a number or ABC or any kind of name, right?
Yes. So if we, for example, if we want to define a list, we can define it like that.
So list and tuples দুটো কি একসাথে ডিক্লেয়ার করা যাবে?
So if we want to define a list, and a tuple, we need to define using two different expressions. One for defining list, one for defining tuple. So
মানে আমি বলতে চাইছি স্যার একটা লাইনের মধ্যে লাইক ম্যাট্রিক্সের একটা এর মধ্যে কি আমি লিস্ট আর টুপল দুটোই কি একসাথে ইউজ করতে পারবো?
এরকম কেস কেন আসবে?
আচ্ছা
মানে একই লাইনে, ধরো একই লাইনে
হ্যাঁ।
আমাদের ধরেন কি করতে হতে পারে, লিস্ট মানে বেসিক্যালি আমরা ম্যাট্রিক্স মানে কি, ম্যাট্রিক্স মানে একটা লিস্ট,
হ্যাঁ
টু ডাইমেনশনাল লিস্ট।
জি স্যার
এখন এমন যদি হয় যে আমরা সেটা মডিফাই করতে চাই একবার ডিক্লেয়ার করার পর, তখন আমরা সেটা লিস্ট হিসেবে ধরবো। আর এমন যদি হয় যে আমরা এমন একটা ম্যাট্রিক্স ডিফাইন করতে চাই যেটা আমরা মডিফাই করব, ধরলাম এমন একটা ম্যাট্রিক্স যেটা স্পেশাল, ধরলাম একটা ফিল্টার, ইমেজ ফিল্টার। নরমালি ইমেজ ফিল্টার তো চেঞ্জ হয় না, এটা একটা জাস্ট
জি
ফিল্টার,
স্যার
কনস্ট্যান্ট। তো তখন আমরা ওইটা আসলে লিস্ট হিসেবে না ডিফাইন করে টুপল হিসেবে ডিফাইন করতে পারি। টুপল ও টু
আচ্ছা স্যার।
ডাইমেনশনাল।
মানে এটা হচ্ছে দুইবার হচ্ছে আলাদা আলাদা করে ডিক্লেয়ার করা লাগবে, রাইট?
লিস্টের জন্য না, no, no. If we want to define two-dimensional list or we can define it like this. So something like that, or for example, not even this. I'm just declaring one here. 1, 2, 3. Four, 5, 6, 7, 8, 9. So it's a matrix, two-dimensional matrix.
জি স্যার
So I hope now it's clear to you. Any more questions?
জি স্যার
Okay, now to define string, we can use one of the three ways. First, we can use double quote like Java or C++. We can use single quote like JavaScript and Python, or we can use triple quotes. So you can define string in three different ways. Now, there's some flexibility. For example, if the string we want to define already has a single quote, we can use double quote, and it will be defined properly. If the string already contains double quote, then we can use single quote, and it will be defined successfully. And similarly for triple quote, if the string has single quote or double quote, we can use triple quotes. Now these sequence types, all of them are zero based. That means the first, if you want to index them, the first element, the very leftmost first element will have index 0, and this is true for all sequence types, not only for tuple or tuple or list. This is true for tuple, this is true for list, this is true for string. For example, if we want to access the element index 1, so it starts from index 0, so index 1 means second element. So now after we define this tuple, now if we want to access element 1, the index for 23 is 0, index for ABC is 1, so we'll get ABC. And similarly, if we have a list like this, and then if you want to access element 1, this is for this index is 0, and we'll get 34. For hello world, for H index is 0, for E index will be 1, so we'll get E. So basically we are we index the leftmost element as 0, and then as we go right, we increase the index 1 by 1. We can also index based on the rightmost element. So that is a flexibility from Python. We can index with respect to the first leftmost element. Also, we can index with respect to the rightmost element. Now, if we want to index with respect to rightmost element, then we start from -1. So that means index for the last element should be -1. So here, the index of this element should be, if we start from left, 0, 1, 2, 3, 4, and if we start from right, then the index will be -1, -2, -3, -4, minus 5. Look, if you have any question, you can ask. Any questions? Okay. Another important concept is slicing. So if we want to find any subsequence, mainly contiguous subsequence, then we use slicing. So 1, 2, 4. That means we'll start from index 1. We'll go the element before index 4. So there are two numbers, start, colon, end. We'll start from the very same number that we write here, and we'll stop at e minus 1. So basically it's an open end. So we'll not go until e, we'll stop just before e. That means we'll stop at e minus 1. So here we want to get a subsequence, contiguous subsequence starting at 1, ending at 3. So that means this is 0. We'll start 1, 2, and we'll stop at 3. So basically we'll return this subsequence. Similarly, we can use negative indexing. We know what will be the index of the element. We can see from here. So now if we put 1 minus 1, that means we'll start at 1, that means we'll start at 1, but we'll stop at the element just before minus 1. That means we'll stop at minus 2. So this is minus 1, this is minus 2. So we'll start at 1. So this is 1. We'll start at 1, and we'll stop the element before minus 1. That means we'll stop at minus 2. So again, we are returning this subsequence. Any questions?
স্যার আমরা যদি ডেফটারেও নিতে চাই তাহলে ওইটা কিভাবে রিপ্রেজেন্ট করব?
Can you please repeat the question?
এই যে পঞ্চমটা যেটা -1 এর ইনডেক্সটাও যদি আমরা নিতে চাই তাহলে কিভাবে করব?
Okay, so I'm coming to that. So if you even want to include the last position, then there are two ways to do that. Basically, one way, there are two ways if you want to include the last and first position. So if we want to include the last position, that means we want to stop at the end. We can keep this number empty. So if we don't write anything after the colon, that means we'll start at 2 and go until we can go. That means we'll start at 2, 0, 1, 2, and from 2 we'll take everything. And also if we want to include the first number, then we keep this position empty. Because we're keeping this position empty, then the compiler will start at the very first it can start. So it will start at 0. And it will take elements until 2. That means it will stop at 2 minus 1, 1. So it will take these 2. Any more questions?
Sir, please repeat. Sir,
Okay,
def যেটা বলেছেন এটা একটু আবার বলেন।
Okay, so we
মানে
can
def এর হচ্ছে যে T2 যেটা ওইটা, হ্যাঁ এটা রাইট।
this one. Okay, so basically if we use colon for slicing means we find contiguous subsequence from a sequence. Now there are positions for two numbers here. We call it start, we call it end. Normally start should be end should be in fact not end, e minus 1 should be in the left side of start.
Okay, sir.
This is the first rule. So if it's not in the left side, then we'll get a return. We'll get an empty sequence because it does not make sense. Now we can put here either two numbers or one number. Now if we put two numbers, then the rule is simple. We start at S and we stop at e minus 1 and then return that subsequence. Now we can keep these two numbers empty. So if we keep the first number empty, that means we are not mentioning the start. We are only mentioning the end. Then the compiler will start at the very first it can start. So but basically it will start from 0. So it will start from 0. So basically this statement is same as T0 colon 2. It is syntactically completely equivalent to T2. And also T2 empty, it's also syntactically equivalent to len of T, because it will stop at len of T minus 1. So this is the last element for that sequence type. Clear?
Yes, sir.
Okay. Now we can also keep we can even not mention both of the numbers. So basically we just putting a colon and not mention any numbers. So then it will start from the very start it can start. So it will start from 0 and it will go until the end of the sequence. So it will go, maybe if the length is n, then it will be like n. So the subsequence will start from 0 and will be until n minus 1th element. From the 0th element to n minus 1th element. That means we'll get the whole sequence as return value. Now in Python, we not only get the whole sequence, Python compiler also makes a separate copy of the list and return it. That means if we use a statement like this statement will make some so it will take some memory, and in that memory it will copy all the elements of L1, and it and the new memory location will be returned for L2. So basically it makes a deep copy of the source sequence type. So that means if we assign the address of one sequence type to another, we are only assigning the pointer value. So if after this statement we modify L2, that modification will be reflected to L1. Now if we make a deep copy of L1 and assign the pointer of the copied region, that means we are basically making a deep copy. So after this statement, if we modify L2, that modification will not be reflected to L1. Clear?
স্যার প্রথমে অ্যাসাইন করে নিতে হবে না পয়েন্টারটা, তারপরে
We'll not have to do anything. So if we want that, just L2
সেকেন্ড লাইনটা লিখবো।
L2 equals L1 L2 equals L1. If we just write just that, then we are making a shallow copy. That means L2, if we modify L2 after this statement, that modification will be also reflected to L1. Now, if we do instead of this, just this, so we are adding 3 more characters. Now we are making a deep copy. So compiler will take care of the memory, allocating new memory, copying the old values, and returning the address to the new memory. So compiler will do that. But this is a deep copy statement. That means after this line, if we modify L2, L1, that modification will not go to L1. Was that your question?
Yes.
Okay. We can use in operator to check membership to a container. So we are putting values into the container. So later, if we need to check, like if this container has this value, we can use in operator. For example, we are defining a list here. So in operator works same for all the sequence types. So we are defining a list here. It could be a tuple. The same thing will work. Now, if we check if 3 in T, now we see that 3 is not in this sequence type, so it will return false. If we check 4 in T, we see that 4 is really inside this list, so we'll get a true. We can also combine in with not to check if this is not a member. Now 4 not in T, but actually 4 is inside T, so we're getting a false value. We can use in for checking substring, and it is very interesting to check for substring using in operator. For example, here we see that we are defining a new string ABCDE. Now we can check if a particular character is a member of this string. So we can check C in A, true. And also we can check for substring. For example, if we check for substring CD, and we see that CD is inside A, CD, so we are getting a true value. Now if we check A, C, we see that A is present, C is present, but it's not a substring of string A. So if we check A, C in A, we are getting a false value. So basically we can check for substring or membership. We can also use plus operator for concatenating strings. We can use plus operator for concatenating strings, and also we can use multiplication operator for making several copies of the source string, source sequence type, and make a new copy with several copies of it. So you can these two operators are overloaded by the library writers. So they overloaded plus operator and asterisk or multiplication operator for sequence types. So this works even for strings, for tuples, and for this. So this is not the same operator as we use. This is, if we look at it, it's same as the mathematical operators, but they are overloaded. So now they have different semantic. So they are used as basically concatenation operator. Now we'll talk about mutability, tuples versus list. In fact, list versus tuples and strings, but the context is different for string. So lists are mutable. That means we can change the elements. For example, here we are defining a list with 4 elements. Now, if we later want to change the second element, index 1 element, 23. Now, if we want to replace it with 44, we can do that per list. So the compiler will not complain. If we do that and then try to read the values, we see that the new list contains values ABC, 45, 4.34, and 23. But this list, when we created it, it has values ABC and 23, but now we replace 23 with 45. So it was possible. Now, if we try to do almost the same thing for tuple, we'll get an error. We'll get an error or exception from the compiler. Here, after defining the tuple, we try to change the index 2 element for this tuple. It was 4.56. Wanted to change it with 3.14, and we are getting an complaint from the compiler. Object doesn't support item assignment. So basically, objects cannot be changed. So there are some advantages of it. We'll talk about advantages in the next slide. So there are some minor details about tuple. If we want to define a tuple, comma is enough. We don't need to use the bracket. We use bracket as nice syntax, but we don't have to. So in fact, if we only use bracket and don't use the comma, it will not be defined as tuple. We see that it is defined as tuple. If we don't use any bracket, only comma, it is defined as tuple. We see that because they are shown like that. So this is right, this is right, but we cannot use only first bracket. Now we can also define tuple using the word or basically the constructor of the sequence type. Sorry, it's just really slow. Hello? Hello, can you hear me? Hello, can you hear me?
Yes, sir. এখন শোনা যায়।
Yes, sir.
So you could not hear me before. Okay. I don't know. Maybe somehow screen sharing stopped. So can you see my screen now?
Yes, sir. We can see your screen.
Okay. Okay. For tuples versus list. So list a little bit slower than tuples because for keeping because lists are mutable. So the library writers need to run some other logics to let it grow when needed or let it shrink when don't need it. Tuples, on the other hand, are write once, read many times. So basically, they're fast. So they need less management code. On the other hand, lists need more management code. This is one case. Another case is tuple can be used to define or initialize multiple variables using just one statement. For example, here we can see that we are initializing x, y, and z to 3 different values. Now, if we used C, C++, Java, then we will need at least 3 different statements for that. In Python, we can use just one statement. Also, we can swap values using just one line. In Python, in Java, C++, it's a classic problem. Normally, we need to use 2 lines. We can reduce that, but still, in Python, we just need 1 line to swap values. However, we can change. In fact, we cannot change. We can create list on the fly from tuple. So here we are using a tuple, mytup, and creating a list with the elements of that tuple. So that means we are creating a new list that has the same elements as the tuple. Also, we can build a tuple using a list. That means we are using the constructor of the tuple container to build a tuple using list. That means we are creating a new tuple and with the values of the list. So then we can use this as a tuple, but basically we are creating a new container, not really modifying it.
Type casting হচ্ছে?
No, you're not doing type casting. We are creating a new container with the values of the old container. So basically we'll get the advantages of tuple from now on, but basically we made a copy of the earlier list, previous list. Similarly here, we are using a constructor. We are using, basically this is not a typecast. These are constructors for those containers. Is it clear?
Yes, sir.
We can also use other data structures like stacks, queues using list. We just need to restrict our access rules to the list, and we know that stacks and queues are called access restricted data structures. So if we restrict our uses of lists, for example, if you want to add new element, we only use append, and when we need to retrieve a new element, retrieve an old element, we only use pop. So if we always use these two functions, append or pop, then effectively lists convert to stacks. Okay, so basically if we want to use a stack, we can start a list and then only use append or pop, then it will behave like a stack. And if we want to want it to behave like a queue, then we need another import. So we import data structure from collections, and then we initialize the deck using a list, and then we only use either append or pop left. So to add new element, we use append. To remove an element, we use pop left. Then it will behave like a queue. So for using stack, we use pop. For using queue, we use pop left. But for adding, for queue and for stack, we use append. And they are all backed by list, because we know that stacks and queues, that may queue, they must be mutable, right? They must be mutable. Otherwise, it does not make sense to restrict the access. So they're mutable and they can grow and shrink. So that's why they are backed by lists. Now, there are some list programming tools in Python. So these are native implementations. So we are not talking about any new libraries. So this is from official Python. So they provide these as functionalities. So we can use list functional tools. There are many. There are mainly three types of functions for that. One is filter, one is map, one is reduce. So all of them, they operate on lists or sequences, and they have the same signature. For example, filter. This is a list programming tool or list programming function. It's a function that takes a function that takes two arguments. One is a function, one is a sequence. And if we check, the signature for map is same. It has two arguments. First one is a function, second one is a sequence. And similarly, reduce, also same signature. First one is function, second one is a sequence. But the signature of the function they take as argument are different. So for example, filter, it takes a function that returns either true or false. This is not the case for map or reduce. So for filter, the first argument, it will return either true or false. And we also provide it a sequence. So this filter function will walk through this sequence. So this filter function will take all the items one by one from the sequence and apply this function f on the elements. Now this function returns either true or false. So for all the elements, this function will either return true or false. And if this function f returns true, the filter will keep it. If it returns false, the filter will remove it. So maybe we'll provide filter function with a sequence of length n, but as a return value, we'll get another sequence that has length less than n. So it's not strictly less than or equal n. Is it clear? I'm giving you some time to think. If you think it's very easy, but maybe it's there are many words to explain, but the work is really simple. It's in the name, filter. It filter out some value. How does it filter out some value? Using function f. So basically it takes a sequence and a function and then applies this function over all the elements of the sequence. And it keeps the elements that returns true.
Sorry, ওই ফাংশন f টা আলাদা করে ডিফাইন করা আছে, রাইট? আর আমরা জাস্ট এটা প্যারামিটার হিসেবে পাস করতেছি।
Yes, we are using it as a parameter. So we'll define the function elsewhere, or maybe we can use lambda function. We can define it the same line, but whatever you use, lambda function is a syntactical sugar. So basically, we will define the function elsewhere and use the function here. Okay, now we'll go to map function. So we know that a filter function will return another sequence of length less than or equals to n, where the length of the original sequence is n. Now map function is different. Map will map the values to different domain. So it will take a sequence as input. It will apply this function f on all the elements of sequence, maybe s, sequence s, and map them to different domain and return the values. That means if we use map function, if the length of the original sequence is n, we'll get back another sequence of length strictly n. So output sequence will also have length n, but the values will be mapped to a different domain. Now reduce function is different. Reduce function will apply function f to all the sequence to all the elements of sequence s, but finally it will return just one value. So now how they work, it's complicated. So just using map reduce, we can solve almost all computer science problems. So there's a proof for that, but this class is not for that. But I'm just showing that these functionalities are or tools are present in Python. So if you know an algorithm that can be only defined using map and reduce, you can do that in Python. So these are the tools, these are the syntaxes for that. Now again, filter will take a sequence of length n, and it can return a sequence of length n of length less than equals to the input length, or less than equals to n. Map will return a sequence of the same length as input, and reduce will always return not a sequence, just a number. Now to delete an element from a sequence, basically it needs to be mutable, that means list. We can use del statement. For del, we can just mention like which element we want to delete. Here we can be fancy, we can use slicing operator, even the all elements, so you can delete the whole delete all the elements from a. So basically we can use delete statement. Now for looping in Python, we use for loop in operator, and this is and basically this must implement the iterator pattern. So basically this is an iterator, and it will give us all the elements one by one in some order, and that order must be defined in the container class. For example, here it's returning the key value pairs, and it's returning key value as tuple. So basically we are assigning the tuple using the same line construct that we just discussed. Now inside the loop we can use those keys and values.
So এটা আবার একটু বলতে পারবেন?
Yes, so basically to use looping in Python, normally we use for loop. So we write for, then we use in operator, and then we write the name of an iterator, and then we start the for block. Now this iterator, depending on the iterator, it can return either a tuple or just a value. Now if it returns just a value, normally we say b. So the value the iterator returns from the container will be assigned to v, and we can use b. Now sometimes it can return a tuple. So if we need to return multiple values, normally we use tuple. For example, key value pair for a map. Then it returns a tuple. Then we can assign the tuple to different variables using this construct. Remember, we use like x, comma y, comma z equals maybe 1, 2, 3. So we use tuple to initialize values for different variables using in the same line. So basically, we're using a construct like this, kv. That means key values will be returned by this iterator, and using tuple rule, they will be assigned to k and p, and then we can use k and p here. Now we will, okay.
যে nights আছে এটা কি একটা map?
Yes, it's a map. Nights dot iter item. So that basically it's a map.
আচ্ছা আমরা যদি just k দিতাম, like k in nights, তাহলে কিরকম আউটপুট আসতো?
So basically, there are different iterators for that. For example, for dictionary, there are 3 different iterators: one for getting key and values, one for getting just the keys, one for getting just the values. Now, if we want to get just the key values, then we use different iterator. Now, if that iterator has a tuple and it's returning tuple for 3 values, and we are trying to assign to 1 value, then it's implementation dependent. So basically, if the implementation, I don't know, if one implementation of Python it thinks that it's an error, then it will throw an error. But another implementation may just use the first value returned. So I'm saying that suppose we are doing like this. X equals 1, 2, 3. Then what should we assign? What should we assign x to? Maybe we can say it's 1. Maybe we can say it's 3 from left to right. So it depends. That's why I'm telling that if we return iterator returns a bunch of values, and we are using just one variable here, it's implementation dependent. So I don't know how to define it. So different implementation can define it differently. Does it make sense? But if we want to get just the key values, we should define another iterator. Maybe it's iter items, maybe dot keys. So it will return only the key values. Another iterator dot values. Maybe it will return just the values. But if we get the key values together, maybe the iterator name is iter items, or maybe just items. So if you want to modify, you need to modify from the iterator's point. Whatever iterator returns, we must accept the values here. Does it make sense to your mind? Okay, I hope it makes sense. Now, if we can, we'll define the other most common data structures, set and dictionary. So if we want to use a set in Python, we can use curly braces, and the elements will be separated by comma, or we can use just comma. For example, basically we're using curly braces here, also here. So we are defining some elements for the set. Also, we can use the constructor of set class and define the set like this. And to add new elements, we can use dot add to add new elements. To check membership, the most common use case for set, we can use the in operator. We can use the in operator to check membership. To remove an element, we can use dot remove. So to add an element, we use .add. To check membership, we use in. To remove an element, we use remove. Now, for other set operations, for example, finding length, we can use len function. To make a deep copy, we can use .copy. Because we don't know how the elements of the set are stored, it depends. It's implementation dependent. There are many algorithms to do that, depending on different efficiency parameter. And also the operations like intersection, union. Now these operations, they are defined using their more textual, complete textual names, or they are also defined using the operators. So Python uses heavy operator overloading. So we can use either the text form or the operator overloaded form for different set operations. Also, there is an iterator for set. So we can just write name of the set and it returns an iterator. So for example, our A in a set, that means we'll iterate over the elements of the set in any order. So we should not assume any order. We can only think that we'll get all the values in some order, and the order is implementation dependent. Now dictionary, the most important data structure of all, that can be used for solving almost all problems. For using dictionary, we can use curly braces, or we can use initial class constructor dict. And then to add a new key values, add a new key and value, we write the name of the dictionary. Inside the bracket, we write the name of the key equals the value. So we really, it really that simple. We just write the name of the key and we assign a new value. Now, because Python is dynamically typed language, the keys need not to be of same objects only. They can be of any object we want. So it's all right if we mix Boolean with double, with integer, with string. So it doesn't matter because it's a dynamically typed language. Now to read the values, we can just mention the key. This is one way. If you want to check other ways, you can check the API. So one of the ways is this. So in the bracket, we write the key value and we get the key and we get the value. We write the key and we get the value. If the value is not present, we get an exception. To get the length of a map, we can use the length function. And to iterate over all the key values, we can use .items. As I said, iter items or items. So items will return a tuple with key and value for each element in the map. If we are interested only in keys or the values, we can use .keys or .values, and then we'll get only the keys or the values. Now to make a deep copy, we can use .copy method. To remove an element, we can use del operator with the key. So if we want to remove an element, we need to know the key of the element. Otherwise, we cannot remove it. To define a function in Python, we already talked about it in the beginning. We basically write def and the name of the function and colon and proper indentation. So this is how we define functions in Python. To return a value, use return statement. And if we need to use default argument, we can use equals in the parameter list, equals, and then the default number. The if else and while loop, while we do not only need to use for loop, we can also use while loop. So for using while loop, the construct is almost as C++ or Java, but it's risky because if you use while loop, then we are responsible for stopping the looping. If we use for, normally we use an iterator and the iterator safely stops the looping. So if you use while, the logic become more convoluted, and also testing becomes harder. But for loops are really easy because they are backed by iterators, and iterators take part of the responsibility. If you can use also if else, just like C++ Java, but instead of else if, we write elif. So very minor difference. Now modules means the libraries, different libraries of Python. So if you want to use libraries, we use import statement, import, then the name of the package. And to use different classes of the package, we use the imported names dot random. Sometimes we can import the class like import random dot random as something. Then instead of writing random dot random, we can use the as after the as, whatever you use that part. But whatever you do, the basic thing is if we want to use some functionalities that's not present in our code, we can use the import statement to import functionalities. We'll discuss Python OOP in next class. Now we'll discuss some of the basically the management stuff for this course. So before I stop, do you have any questions? Any questions? Okay, I'll take that there are no more questions. So I'm stopping sharing now.
স্লাইডটা কি শেয়ার করা হবে আমাদের ক্যানভাসে?
আমি স্লাইডটা শেয়ার করব ক্যানভাসে। আচ্ছা, এবার আসি আমরা কোর্সের এক্সপেকটেশন কি হবে সেটা নিয়ে। আমাদের আসলে কোর্সের এই কোর্সের যে টোটাল কন্টেন্ট, সেটা আমার একটা ফাইল আছে, সেই ফাইলটা আমি শেয়ার করব। আমি এখন মুখে বলি। এই কোর্সের টোটাল আমাদের 5 লেকচারটা ছিল হচ্ছে আজকে যেটা কন্টেন্ট, যে ইন্ট্রোডাকশন টু মেশিন লার্নিং, আর হচ্ছে পাইথন। আর পাইথনের অল্প কয়েকটা স্লাইড বাকি আছে, সেটা আমরা নেক্সট ক্লাসে শেষ করে ফেলবো। আর তারপরে নেক্সট ক্লাসে আমরা যেটা দেখবো সেটা হচ্ছে মেইনলি নিয়ারেস্ট নেইবার অ্যালগরিদম, মানে সবচেয়ে বেসিক যে মেশিন লার্নিং অ্যালগরিদম, যেটা বোঝা সবচেয়ে সোজা। নিয়ারেস্ট নেইবার অ্যালগরিদমটা দেখবো। আর হচ্ছে আমরা কিছু প্রবাবিলিটি রিভিউ করব, যে প্রবাবিলিটি রুল গুলা কি কি। এবং প্রবাবিলিটি মানে হচ্ছে যে স্যাম্পল স্পেস, তারপরে হচ্ছে ডিস্ট্রিবিউশন বলতে আমরা কি বুঝি, তারপরে বেস প্রবাবিলিটি বলতে আমরা কি বুঝি, এই রুলটা কিভাবে আসে, তারপরে ডিপেন্ডেন্ট ইন্ডিপেন্ডেন্ট র্যান্ডম ভেরিয়েবল গুলা কি জিনিস, তারপর হচ্ছে কোরিলেশন কোভেরিয়েন্স কি জিনিস, এই ধরনের বেসিক কনসেপ্ট গুলো যেগুলো হচ্ছে আমাদের মেশিন লার্নিং এর অ্যালগরিদম গুলো বুঝতে কাজে লাগে, সেগুলো ডিসকাস করব। আর সাথে হচ্ছে নিয়ারেস্ট নেইবার। আর তারপর হচ্ছে আমাদের এটা হচ্ছে আমাদের সেকেন্ড লেকচার। তো থার্ড লেকচারে আমরা মেইনলি দেখবো হচ্ছে যে বেসিক লিনিয়ার অ্যালজেব্রা। মানে ব্রেকের আগে পরে দুইটা পার্ট। ব্রেকের আগে আমরা দেখবো হচ্ছে লিনিয়ার অ্যালজেব্রা কি, এবং এই লিনিয়ার অ্যালজেব্রা দিয়ে আমরা কিভাবে মেশিন লার্নিং মডেলগুলো ইন্টারপ্রেট করি। এবং তারপরে দেখবো হচ্ছে আমরা এমন একটা মেশিন লার্নিং মডেল যেটা হচ্ছে আমাদের এই যে প্রবাবিলিটি রিভিউটা আমরা করব, এবং এই যে বেসিক লিনিয়ার মডেলটা আমরা লিনিয়ার অ্যালজেব্রা আমরা শিখবো। এই দুইটা জিনিস ইউজ করে একটা মেশিন লার্নিং অ্যালগরিদম, এটার নাম হচ্ছে বেসিক্যালি মানে অনেকটা এটা বলে জেনারেটিভ অ্যালগরিদম। বেসিক্যালি মানে হচ্ছে এই যে বেস রুল, মানে বেস রুল ইউজ করে কিভাবে ক্লাসিফাই করা যায় সেটার মানে নাটস এন্ড বোল্টস গুলা। তার মানে প্রথমে আমরা আজকে হচ্ছে আমরা দেখতেছি পাইথন প্রোগ্রামিং, আর তারপরে দেখবো হচ্ছে আমরা সবচেয়ে সহজ মেশিন লার্নিং অ্যালগরিদম নিয়ারেস্ট নেইবার। তারপরে দেখবো হচ্ছে আমরা প্রবাবিলিটি, লিনিয়ার অ্যালজেব্রা, এবং তারপরে লিনিয়ার অ্যালজেব্রা দেখার পর এই প্রবাবিলিটি এবং লিনিয়ার অ্যালজেব্রা ইউজ করে কিভাবে একটা মেশিন লার্নিং মডেল ডিক্লেয়ার করা যায়, জেনারেটিভ মডেল বা বেস মডেল, সেটা আমরা দেখব। আচ্ছা, সেটা দেখার পর আপনারা মোটামুটি সবাই এক্সপার্ট না, মানে সবাই বুঝতে পারবেন যে যারা এখনো মেশিন লার্নিং এর টাচ তেমনটা আসেন নাই, যে মেশিন লার্নিং আসলে কি জিনিসটা বা কিভাবে এটা নিয়ে প্রজেক্ট করা যায়। এরপরে ক্লাস হচ্ছে আমরা ডিসকাস করব প্রজেক্ট নিয়ে। আপনারা মানে একটা করে আইডিয়া দিবেন, সেই আইডিয়াটা আবার আমি একটু জাজ করে দেখবো যে কতটুকু ভালো শেখা হবে কিনা, ওটাতে একটু হয়তো মডিফাই করে দিব এবং সেটা আপনাদের কোর্সের প্রজেক্ট হিসাবে তারপরে করতে হবে। এরপর হচ্ছে আমরা লিনিয়ার রিগ্রেশন, তার মানে আমরা অলরেডি লেকচার নাম্বার 3 বললাম যে কি করব। লেকচার নাম্বার 4 হচ্ছে আমাদের লিনিয়ার রিগ্রেশন এবং লজিস্টিক রিগ্রেশন। একদিনে আমরা দুইটা করব, হাফ হচ্ছে লিনিয়ার রিগ্রেশন, হাফ হচ্ছে লজিস্টিক রিগ্রেশন। তো এখানে একটা ক্লাসে দুইটা করার উদ্দেশ্য হচ্ছে আসলে লিনিয়ার অ্যালজেব্রা হচ্ছে বেসিক্যালি একটা ভ্যালু বের করে, কন্টিনিউয়াস ভ্যালু আউটপুট যখন থাকে, আর লজিস্টিক রিগ্রেশন হচ্ছে অনেকটা সেটা একটা প্রবাবিলিটি বেস দেয়, যে আমরা একটা আউটপুট বের করলাম। অনেক সময় হয়তো আমরা আউটপুট বের করে হচ্ছে মোর ইন্টারেস্টেড থাকি যে এই যে আউটপুটটা, এটা প্রবাবিলিটি আসলে কেমন, মানে থ্রেশহোল্ড কোন জায়গায়। তো বেসিক্যালি প্রবলেমটা তখন যেটা হয় রিগ্রেশন থেকে ক্লাসিফিকেশনে কনভার্ট হয়ে যায়। তো ওই জিনিসটা আমরা একটা ক্লাসে দুটো জিনিস কভার করব। এটা হচ্ছে লেকচার 4। আর যদি ক্লাস নাম্বার বলি, এটা ক্লাস নাম্বার 5, কারণ একটা ক্লাসে হচ্ছে আমরা ওই ডিসকাস করব হচ্ছে যে কিভাবে প্রজেক্ট গুলা। তারপর হচ্ছে ফিফথ লেকচার বা 6th ক্লাস। আমি বলতেছি,
স্যার শুনতে পাচ্ছি না।
না আমি এখন কথা বলিনি, আমি বলতেছি, আমি একটু জাস্ট লোড করে
Okay,
নিতে
sir.
থাকি।
জি।
আমার একটু লোড হইতে সময় লাগতেছে আর কি। আচ্ছা, আমরা ডিসকাস করছি হচ্ছে লেকচার 4 পর্যন্ত। আচ্ছা, লেকচার 5 হচ্ছে বেসিক্যালি আমাদের সাপোর্ট ভেক্টর মেশিন। ঠিক আছে, এটা আরেকভাবে বলতে গেলে লিনিয়ার ক্লাসিফিকেশন বাউন্ডারি। তো আমরা সাপোর্ট ভেক্টর মেশিন, তারপর হচ্ছে যে এটা কিভাবে অপটিমাইজেশন করা হয়, অপটিমাইজেশনের সময়ে যদি সেপারেবল হয় তখন কি করা হয়, নন সেপারেবল হলে কি করা হয়, সেই ধরনের কেস। এবং ফাইনালি আমরা দেখবো যে কার্নেল ট্রিক নামে একটা জিনিস আছে, তারপর হচ্ছে বেসিস এক্সপানশন নামে একটা জিনিস আছে, সেটা আমরা কিভাবে করি, এবং সাপোর্ট ভেক্টর মেশিন দিয়ে আমরা রিগ্রেশন প্রবলেম কিভাবে সলভ করি, ক্লাসিফিকেশন প্রবলেম কিভাবে সলভ করি, মাল্টি ক্লাস হলে আমরা কি করি, এই ধরনের কেসগুলো। এটা আমরা একটা ক্লাস, এটা যেহেতু অনেকগুলো টপিক, আমাদের আসলে ফুল একটা ক্লাসই এটার জন্য লাগবে, মানে 3 আওয়ার্স লাগবে এটার জন্য। এটা গেলো আমাদের 5th লেকচার বা 6th ক্লাস। আর 6th লেকচারে হচ্ছে একটু লোড হইতে সময় লাগতেছে। 6th লেকচার হচ্ছে আমরা এনসেম্বল মেথড গুলো দেখবো, মেইনলি হচ্ছে ডিসিশন ট্রি এবং র্যান্ডম ফরেস্ট। এগুলার আমি জানি না সবগুলো কভার করতে পারবো কিনা, তবে যেহেতু একটা মাত্র লেকচার, অথবা যদি মানে এরকম হয় যে দুইটা লেকচার লাগে, না হয় লাগলো, কারণ এই ডিসিশন ট্রি এবং র্যান্ডম ফরেস্ট দুইটারই একটা হচ্ছে ক্লাসিফিকেশন এবং রিগ্রেশন, মানে 2 টাইপস অ্যালগরিদমস, দুইটার জন্যই এটা হচ্ছে আমাদের 6th লেকচার বা 7th ক্লাস। তারপর হচ্ছে আমাদের 8th ক্লাস। 8th ক্লাস হচ্ছে আমাদের আমরা কিভাবে মডেল, আমরা যেটা বললাম যে মডেল ইভ্যালুয়েশন, মডেল সিলেকশন, এটা হচ্ছে আমাদের 8th ক্লাস। এবং এই 8th ক্লাসের আগেই একটা মিড টার্ম হবে। 8th ক্লাসের কন্টেন্ট একটু ছোট, যেহেতু মিড টার্ম আমাদের একদিন নিতে হবে, ওই মিড টার্মের দিনে আমরা একটু কম কভার করতে পারবো, এটা মনে করে 8th লেকচারটা একটু ছোট হবে আর কি। হয়তো অন্য লেকচারের মধ্যেই মিড টার্মটা হবে, কিন্তু ওই লেকচারের পার্টটা আস্তে আস্তে যতদিনে 8th লেকচারে আসবে ততদিনে আশা করি আমাদের কভার হয়ে যাবে। তার মানে আমাদের অলরেডি 9টা ক্লাস হয়ে গেল। 9th ক্লাসে আমরা যেটা করবো নিউরাল নেটওয়ার্ক করব, এবং বেসিক্যালি ফিড ফরওয়ার্ড নিউরাল নেটওয়ার্ক। আর 10th ক্লাসে আমরা করব হচ্ছে কনভলিউশন নিউরাল নেটওয়ার্ক। 11th ক্লাসে হচ্ছে আমাদের প্রজেক্ট প্রেজেন্টেশন হবে, মানে আপনারা যে প্রজেক্ট করছেন সেটা শো করবেন এবং সেটা ইভালুয়েট করা হবে।
তো
আর
আপনি কি কোনো ফাইল মানে কোনো
আমি
ফাইল
সবকিছু শেয়ার
আপলোড
করব।
করছেন?
আমি এখন আপলোড করিনি, আমি সবগুলো শেয়ার করব। আমি শেয়ার করব আপনাদের এই ফ্রাইডের মধ্যে। আমার কিছু কোর্স ম্যানেজমেন্টের জন্য আমার একটু সময় লাগতেছে আর কি। এগুলো সব লেকচার সবগুলো আপনাদের সাথে শেয়ার করব, কিন্তু আমি শুরু করব হচ্ছে শেয়ারিং শুরু করব হচ্ছে ফ্রাইডে থেকে। মানে প্রথমে আমি শেয়ার করব হচ্ছে লেকচার 1 আর হচ্ছে এই যে কোর্স আউটলাইন, যেটা আমি এখন মুখে বলতেছি সেটা আমাদের কন্টেন্ট
এখন
গুলো থাকবে।
আসলে জিনিসটা হলো আপনি যে মুখে মুখে বলতেছেন না, দেখা যাবে যে আধা ঘন্টা পরে আমরা ভুলিয়ে যাব যে আপনি সেকেন্ড ক্লাসে কি পড়াবেন, থার্ড ক্লাসে কি পড়াবেন, একটু মানে মাথার উপরে দিয়ে যাচ্ছে।
এটা আপনার পাবেন, লেকচার ফ্রাইডেতে আপনারা পাবেন আউটলাইনের মধ্যে এই পুরো অর্ডারটা লেখা থাকবে, কোন লেকচার পর কোন লেকচার। আর এই লেকচার শিট
স্যার
এটা
বুক
আপনার
কি দেওয়া হবে, টেক্সট বুক, পিডিএফ?
পিডিএফ কোনো টেক্সট বুক আসলে ওইভাবে নাই। আমি আপনাদের রিডিং গুলা দিয়ে দিব হচ্ছে বিভিন্ন ভাবে, যেমন বেশ কিছু লেকচার আউটলাইন আমি ফলো করি। ওই যেমন ডিপ লার্নিং এর জন্য কতগুলা লেকচার নোট আছে, সেই লেকচার নোট গুলো হচ্ছে মানে খুব বুক চ্যাপ্টারের মতো, তো সেগুলো আমি শেয়ার করব। আপনাদের ক্যানভাসে স্ট্রাকচারটা দেখলেই বুঝতে পারবেন, সেখানে স্ট্রাকচার করা আছে যে লেকচার, রিডিংস, এক্সারসাইজ। আপনার ওইখানে কন্টেন্টটা এই ফ্রাইডে থেকে পাওয়া শুরু করবেন আর কি।
স্যার আপনি হচ্ছে কন্টেন্টটাও দেন, আর হচ্ছে যে মানে প্রেজেন্টেশন বা ক্লাস যে কুইজ যেটা আর কি, সেটাও আর কি মানে করে দিয়েন, স্লাইডটা দিয়ে কুইজ ওর যেটাই নেন আর কি। আমি জানি না আপনি কিভাবে নেবেন, তো ওইটার
আচ্ছা, ওগুলো সব পাবেন আপনারা, মানে কোর্স কন্টেন্ট ক্যানভাসে সব থাকবে। ক্যানভাস তো আপনার মানে আগে থেকে সব পপুলেটেড থাকে না, যেটা যেটা আপনার লেকচার হবে সেটা আপলোড করে দেওয়া হবে আর কি। ব্যাপারটা বুঝতে
স্যার
পারছেন?
আজকে
মানে
রেকর্ডিংটা কি পাওয়া যাবে?
হ্যাঁ, রেকর্ডিংটাও আমি দিব।
আচ্ছা
মানে রেকর্ডিং, লেকচার সব আপনারা পাবেন। হ্যাঁ বলেন। আচ্ছা, ওইটা আমি আসতেছি, লেকচারটা শেষ করে তারপরে এক্সামে আসবো। আচ্ছা, আমাদের ফাইনাল 11th লেকচার হচ্ছে কনভলিউশন নিউরাল নেটওয়ার্ক। আর তারপরে একটা ক্লাস আমি স্ল্যাক হিসেবে রাখছি, যে ওইটার মধ্যে আমরা যদি কোনো কন্টেন্ট এর মধ্যে শেষ না হয়, যেন আমরা ওই একটা ক্লাস ইউজ করতে পারি। কারণ অনেক সময় দেখা যায় যে আমি যতটুকু টাইম চিন্তা করি তার চেয়ে অনেক সময় বেশি লাগে। অনেক সময় কোনো টপিক হয়তো আমি যে চিন্তা করলাম তার চেয়ে কঠিন থাকে, এটা নিয়ে অনেক ডিসকাস করতে হয়। তো এই জন্য একটা ক্লাস স্ল্যাক রাখছি, বা যদি এমন হয় যে আমরা ক্লাসে আপনাদের ফাইনালটা নিতে পারি, ফাইনাল ক্লাসে সেটাও করা যেতে পারে, আমি জানি না। এই জন্য একটা ক্লাস স্ল্যাক হিসেবে রাখছি আর কি। আর যদি ওই স্ল্যাক ক্লাসটা আমরা মানে না লাগে, সেক্ষেত্রে সেখানে আমরা ক্লাস্টারিং, টিসনি এবং কতগুলো আনসুপারভাইজড মেথড সেগুলো ডিসকাস করব, বা ডাইমেনশনালিটি রিডাকশন, যেমন পিসিএফ, এই ধরনের কিছু হয়তো আমরা ডিসকাস করব। পিসিএ এর সাথে হচ্ছে নিউরাল নেটওয়ার্কের একটা এক্সটেনশন আছে, নাম হচ্ছে অটো এনকোডার। হয়তো পিসিএ এবং সাথে অটো এনকোডার, একটা লিনিয়ার একটা নন লিনিয়ার, এই দুটো ডিসকাস করে দিলাম আর কি। তো এই হচ্ছে আপনাদের কোর্সের কন্টেন্ট। তার মানে কোর্সের কন্টেন্ট হচ্ছে, আমি যদি জাস্ট নামে বলতে চাই, লিনিয়ার রিগ্রেশন, লজিস্টিক রিগ্রেশন, সাপোর্ট ভেক্টর মেশিন, এনসেম্বল মেথডস, নিউরাল নেটওয়ার্কস বেসিক, আনসুপারভাইজড কতগুলো টেকনিক, এই হচ্ছে আপনাদের কোর্সের কন্টেন্ট। এবার আসি এক্সাম। এক্সাম হবে আপনাদের একটা মিড টার্ম, একটা মিড টার্মে হবে হচ্ছে আপনাদের 30% নাম্বার, একটা ফাইনাল 30% নাম্বার, তারপর হচ্ছে দুইটা কুইজ হবে। দুইটা কুইজ হচ্ছে বেস্ট ওয়ান কাউন্ট করব, এটা হবে 15%। তার মানে আপনাদের হলো 30, 30, 60, 75%। ক্লাস প্রেজেন্স হচ্ছে 5%, তার মানে টোটাল হচ্ছে 80%। বাকি 20% হচ্ছে কুইজ, সরি প্রজেক্ট। তার মানে প্রজেক্টটা খুব ইম্পর্টেন্ট। ঠিক আছে, এই হচ্ছে টোটাল 100%।
স্যার প্রজেক্ট কি গ্রুপে নেওয়া হয় নাকি ইন্ডিভিজুয়াল নেওয়া হবে?
প্রজেক্ট রিকমেন্ডেড হচ্ছে দুজনের গ্রুপ করা, কারণ একজন করলে যেটা হয় আবার বেশি লেজি হয়ে যায়, আবার তিনজন করলে যেটা হয় যে সবাই একজন একজনের উপর ডিপেন্ডেন্ট থাকে, দুজন হচ্ছে বেস্ট গ্রুপ। আর যদি আপনি একজন করতে চান কোনো অসুবিধা নেই, সেটাও করতে পারেন। তো আমার রিকমেন্ডেশন হচ্ছে দুজনের গ্রুপ করা, তিনজনেরও না, একজনেরও না। আর প্রজেক্টের জন্য এটাই হচ্ছে গাইডলাইন গ্রুপের। আর প্রজেক্ট কিভাবে সিলেক্ট করবেন, এই জন্য আমি প্রজেক্টের আগের ক্লাসে আপনাদের কতগুলো ওয়েবসাইট দেখাই দিব, যেখানে আগের ক্লাসে না, হয়তো নেক্সট ক্লাসে দেখাই দিব কতগুলো ওয়েবসাইট যেখান থেকে আপনার ডেটা সেট কালেক্ট করতে পারবেন। তারপর হচ্ছে বিভিন্ন প্রজেক্ট মানুষকে কেমন করে সেটা নিয়ে আইডিয়া নিতে পারবেন। তো সেখান থেকে আইডিয়া নিয়ে একটা প্রজেক্ট করবেন আর কি।
স্যার কোনো কিছু বেসড অন হইতে হবে, যেমন ধর পাইথনই ইউজ করতে হবে বা এরকম কোনো শর্ত আছে?
এরকম কোনো শর্ত নাই, আপনার তো মানে কোনো একটা ল্যাঙ্গুয়েজ ইউজ করতে হবে, তাই না? আর ইউজ করতে পারেন, পাইথন ইউজ করতে পারেন, অনেক আছে মানে কি নাম আছে না, জুলিয়া নাকি জুলি এরকম একটা নাম, ওইটা অনেক ইউজ করতে চায়, মানে আমার কোনো অসুবিধা নেই। কিন্তু সমস্যা হচ্ছে যে মানে রিসোর্স তো বেশি হচ্ছে বেসিক্যালি, মানে আর একটু কম বলবো না, আর এবং পাইথনের রিসোর্সই বেশি। তো যদি চান আর ইউজ করতে পারেন। আমি মেইনলি দেখবো যে প্রজেক্টের আউটকামটা কি, মানে আপনি কতটুকু ক্লেম করছিলেন শুরুতে এবং শেষে কি আউটপুট দিলেন, এটা।
আর 3 জনের গ্রুপ কি অ্যালাউ করা হবে?
তিনজনের গ্রুপ আমি অ্যালাউ করতে পারি, কিন্তু আপনাদের আর কি আলটিমেটলি দেখা যাবে কাজ স্লো হয়ে যায়। আপনাদের আর কারো কোনো কনসার্ন বা কোশ্চেন আছে?
স্যার আমরা যে প্রজেক্ট করব এটা কোন সফটওয়্যার কোনো রিকমেন্ডেশন আছে? হ্যালো
হ্যালো, হ্যাঁ কি বললেন?
স্যার আমরা কোন সফটওয়্যার ইউজ করব ওটা যদি একটু বলে দিতেন।
আচ্ছা, আপনি যদি পাইথন ইউজ করেন তাহলে অ্যানাকোন্ডা ইউজ করেন।
আচ্ছা
আর যদি আর ইউজ করেন সেক্ষেত্রে আর স্টুডিও নামে একটা টুল আছে, মানে সফটওয়্যার আছে, যেটা ইউজ করতে পারেন। অ্যানাকোন্ডা খুবই সহজ আর কি, আপনি সব গ্রাফিক্যাল ইন্টারফেস আছে, সেখানে আপনি কি প্যাকেজ লাগবে সেটা ইনস্টল করা, ওই প্যাকেজ ইউজ করা, বা নতুন কোনো এনভায়রনমেন্টে যাওয়া, সেগুলো খুবই সহজ আর কি।